All right, welcome everyone. So we're going to be doing a light introduction to advanced functions today. So nothing too big, some review. Some of us haven't done math in a year, so it will be good for us to get our knowledge back from grade 11. In grade 11 we did some trig, some rationals, some polynomials, and some log because we're doing AP. So we snuck that in there, and now let's just review. So the goal of today is to represent and describe functions and their characteristics, and start with question 1. So these are questions that we actually did before, and you likely did that before. So let's go ahead and look at this. Jonathan and Tina are building an outdoor skating rink. They have enough materials to make a rectangular rink with an area of about 1,800 meters squared. And they do not want to purchase any additional materials. They know from past experience that a good rink must be approximately 30 meters longer than it is wide. So let's go ahead and do this. So obviously there are two ways you could do this, one variable, two variable. We want to do the two variable way just because we're advanced. So let's state our let statements. Make sure that you're always writing our let statements. That is basically 1 out of 5 for these type of questions. So let x represent the length and let y represent the width. Alright, and then we could define all of our variables. So a is equal to a area, or a in short, is equal to x times y. And then we know that the area is roughly 1,800, so we could just write 1,800 equals to xy. So we could choose a term to write. We could choose a term to write our equation for. So let's say I want to isolate for y. So y is equal to 1,800 over x. Or I could write x, that's just 1,800 over y. So either way, we're now able to do these two functions, and they're interchangeable now with each other if we have another equation. So most of the time we know, and from past experience that we know, for this type of cases, we will always need another equation, so we could substitute in and do some algebra. So where is our second equation? Well, we read the question. We notice that they know that a good rink must be approximately 30 meters longer than it is wide. So what does that mean? So we could let a function here, let f of x represent the difference between x and y, or in other words, the length and the width. So what is f of x? So f of x is equal to x minus y. And we also know that f of x is equal to 30. F of x is equal to 30. And we also declare that y is equal to 1,800 over x. So what does that mean? So f of x is equal to x. So if we substitute in, 30 is equal to x minus 1,800 over x. And now all we need to do is just solve this algebraic equation. So let's multiply both sides by x, so we get rid of this fraction. So we get rid of the x in the denominator. So 30x is equal to x squared minus 18,000. And that just becomes a quadratic equation for us. So x squared minus 30x minus 1,800 is equal to 0. We look at it. The best way is to solve a quadratic equation is always do by factoring, not by quadratic formula, because that is very inefficient. And we realize, oh, here we go. We could just factor it. Minus 60 plus 30 is equal to 0. And using the zero product principle, stating that when we have two x values and they multiply each other to equal to 0, then one of them must be equal to 0. So x equals to 60 equals 0, x equals to 60, or x plus 30. So 30 is equal to 0, and x equals to negative 30. And since we're talking about length here, as we are talking about length slash width slash dimensions, we know that the values cannot be negative. So x equals to 60. Now since the difference is 30 meters, so f of x is equal to x minus y, or 30 is equal to 60 minus y, so y is equal to 30. Therefore, the dimensions are 60 meters times 30 meters. Make sure to always state your units, and will produce an area of about 18 meters squared. Okay, there we go. We have done this first question. Hope you are slowly getting your knowledge back from grade 11. Shouldn't be that hard. Should be pretty straightforward for you, because we did a lot of these last year. Well, you should have. Alright, let's go on to question number 2. This is just a very simple question identifying if one of these is a function or a relation. So let's discuss about this a little bit. So we see example 2a. Clearly this is a function because this is an exponential function, as we learned this last year. And we notice that we also have to state the domain and range. So let's go ahead and make another. Well, I'll write on this one because there's notations. It's going to be complicated. So let's look at this. So obviously this is a function and it passes the vertical line test, which does not let me write right now for some reasons. Okay, there we go. Okay, so it passes the vertical line test, and the vertical line test states that if we draw a vertical line on the graph of a function, at most the line will only pass through a single point. So we realize that every line we draw vertically, that was not intention. So every line that we draw vertically, there's only one. There's only one point that touches the line. We know that this function passes, and he is a function, and he is an exponential function, or she. So it is an exponential function. So let's discuss the domain and range. So the domain, we observe the function, we realize, okay, so it's x such that x is all real numbers. What about the range? Well, we see that the range clearly has a down point. So range such that y such that domain range y such that we notice a lower point, and that lower point is -2. So every y value, so y is equal to every real number, but y has to be greater. Now we have to debate, is it greater or equal to, or is it greater? So we notice there's an asymptote. We know there's an asymptote at -2. So it's only y that's greater than -2. And there we go. We have our answers. Okay, domain. Alright, let's go ahead and move on to B. So we have a function right here because it's a rational function. And we learned this last year. So this is a function. So I'll just give a check mark. Function, we know. So it's a function. But we have to talk about the range and domain. So for complicated rational functions, it's often hard to tell about the range. But for such a simple rational function, it's pretty easy. So let's see. Is there any possible x values that it cannot take? Well, we notice that if we have x equals to 0, there's a vertical asymptote and it doesn't give us anything. And besides that point, the function is fully defined. So we will have to write x is all real number, but x doesn't equal to 0. Because there is a vertical asymptote. And let's look at the range now. So the range, so we could visualize this graph a bit. Notice it's an even, so this is an even vertical asymptote. Well, so what does 1 over x squared look like? So I hope you took a little bit of time there to draw it yourself. But remember that 1 over x is this. This is 1 over x. So 1 over x squared is nothing different. It's going to be pretty much the same. Right? So how does it go? So we know that we have an even vertical asymptote at 0. So it must look something like this. Both goes up. Right? This is something that looks like. So we know that the y value will always be greater than 0. And we notice that there is a horizontal asymptote here. How do we know? Because as for this function, as our x gets very big, all the way to the right. This function is 1 over something, but it's never 0. No matter how big x is, it will never be 0. So y is all real number, but y is still greater than 0. And let's look at c. So c is very simple. C is very easy. So c, let's see. Is it a function? So a function we need every x to be unique. So at every x point, we can only have one y value. We cannot have two y values at one same x values. So let's see, does it match? So the x on the left, so -2, 0, -1, 0, 0 is 1, 2, so it's okay. 1, 2, 2, 3. So we see that every x value only corresponds to one y value. So we are fine. This is a function. And since we have a list, our domain is actually specified. So it's every number in this list. -1, 0, 1, 2. And our range is just the same. 0, 1, 2, 3. Okay, and now we're done. So let's go ahead and move on to example 3. Using reasoning to determine the domain and range of a function. Neil rides a Ferris wheel that has a diameter. Notice its diameter, so d equals to 6. Okay, I should probably, since we're dealing with trig here, let's do a text box. So d diameter equals to 6. Radius is equal to 3. Just gotta do that for you. Ooh, radius equal to 3. Okay, there we go. The axle of the Ferris wheel is 4 meters above the ground. The Ferris wheel takes 90 seconds to make one complete rotation, and Neil rides for 10 rotations. That's a lot. What are the domain and range of the function that models Neil's height above the ground in terms of time while he rides the Ferris wheel? So obviously we had to go ahead and get our full function notation for anything like a sinusoidal function or a cosine function. So let's decide. Are we gonna use a sinusoidal function or a cosine function? We don't know exactly, and the question doesn't ask us to do that. The question asks to determine the domain and range of the function. So let's go ahead and do this. So height at time t is equal to a sine of k t minus d or t minus p, as we did last year, plus q. This is our general formula, or h of t is equal to a cosine k t minus p plus q. This is our general formula that we remember from last year. So let's look. What is the domain? Well, the domain is time. Time is our vex variable. Time is our variable on the x-axis. So what is time? We have already defined time. He rides for 10 rotations, and each rotation is 90 seconds. So time, as we know, time cannot be 0, and time can be 0, that's when we started, but time cannot be negative. So domain is t equals all real number, but 0 is less or equal to t is less or equal to 90 times 10, which is 900. And make sure we specify t is in seconds. You could miss this specifying part, but it's okay. Now let's draw a brief diagram to show us what are we trying to do? What is our range? Because range is usually harder to figure out. X is much easier. So the axis of the Ferris wheel, which is 4 meters above the ground. And then we have the diameter, which is 6. So this is 6, and so it means this part is 3, this part is 3. So let's draw a wheel. So what can we notice? If here is the ground, it doesn't let me draw again. If this is the ground and this is 4 meters and that is 3 meters, then there we have left, then this place that we have left is just 1 meter. So this is 1 meter, so that's our lower bound. 1 is less than, so what, or equal to, what's our upper bound? 4 plus 3. Y, or height, since we defined it. 4 plus 3, and there's a 7. So let's go ahead and fill in a text box because we like the text box. And range is equal to height equals all real number. And we talked about why it's all real number. It's because there's no gap. He doesn't jump from this height suddenly to that height. He doesn't jump. This is defined. Every movement is defined here. So it has to be all real numbers. So 1 is less or equal to y, or height is less or equal to 7. And there we go. We have finished this entire 1.1 function review, slightly introductory to advanced functions. So I hope you guys are doing good. I have linked the textbook that we're using, basically the Nelson Advanced Function 12 textbook. There are homework for you to practice with on page 11, 12, and 13. And in 1.2, which is tomorrow, we will be exploring the absolute value function.